thanks for that introduction, and it's a pleasure to be here in Geneva talking to an audience who's interested in what I think is probably the most important topic on the planet today, which is how to orient artificial intelligence as it becomes smarter and smarter, how to orient it toward the broad benefit of humans and all sentient beings. I think there are three key things we need to think about when we think about how to make AIs beneficial and benevolent. I mean, one is, what's the architecture inside the AI system itself? How does its mind work? Does it understand what it is? Does it understand what beings it's talking to? Is it architecturally capable of real empathy and compassion, of being a moral agent? And I think, for example, ChatGPT, large language models, such as are popular now, really don't fulfill this criterion yet. Whether that's a problem or not is a different question, because they're also not capable of doing that much on their own yet. But I think thinking about the cognitive architecture underlying the AI and whether it's fundamentally morality and compassion capable is very important. Another very important aspect is who owns and controls and guides the AI. And of course, if you look at human beings, every human has a cognitive architecture capable of moral agency and compassion. I mean, perhaps not a very small percentage of sort of genetic psychopaths, but it's a tiny portion of the population, right? But then, depending on how a human is raised, then this fundamental capability for moral agency and compassion may be, it may be manifested in a full-on and impressive way, or it may be in the background, right? And similarly, for AI, even with the right architecture, to manifest its capability for good, the AI has to be guided in the right direction. And if you look at what AI is used for on the planet primarily today, so I used to say, before ChatGPT, I used to say it was mainly used for selling, killing, spying, and crooked gambling, the latter being Wall Street. Now, with ChatGPT, we can add to selling, killing, spying, and crooked gambling, we can add plagiarism and cheating on your homework, right? I mean, on the whole, I mean, all these they're part of the human experience, fine. I guess they've got to exist, right? But on the other hand, there's a lot of other things AI could be used for. I mean, there's no logical reason every kid doesn't have an AI tutor helping them do their homework, rather than just helping them cheat on their homework. Not replacing a human teacher, but filling in when the human teacher is busy to answer quick questions. And there's no reason we don't have AIs, by a patient's bedside in the hospital or an elder care facility. Getting onto what I'm going to be demonstrating with the Grace robot shortly. And in terms of scientific discovery and artistic creation, there's all sorts of ways AIs could be used to enhance what humans do. The business models aren't as clear for these things as for advertising, espionage, and so forth, right? So this comes down to who owns and controls the AI. If an AI is owned and controlled by a government seeking its own sovereignty and interests over other governments, or by a company seeking its own profit and shareholder value, which is what the companies and governments are sort of configured to do, that's going to be different than if an AI is controlled in a more participatory and democratic way by a wider swath of humanity. And if you look at the internet and look at Linux, these are two beautiful examples of more open, decentralized systems. They're not controlled by some precise democratic voting mechanism, but they're controlled in a participatory way by a broad global network of people. And I think they are, the internet and Linux both are largely evolving for the common good of the human species in a sort of democratic and participatory way. So I've talked about the architecture inside the AI. I've talked about who owns and controls the AI, and I sort of verge into the third part, which is sort of what is the AI doing day by day, because what you do day by day influences how your mind works, right? And if you're trying to sell people junk they don't need online every day, and that's your main pursuit, that's going to influence what happens in your own brain, right? Whereas if you're trying to help elderly people through the last years of their life, you're trying to help children learn, I mean, then that's going to influence what's happening in your mind, whether you're a human or an AI. So I think, on the whole, if we want to move toward beneficial AI at this unique period in history when AI is getting smarter and smarter and perhaps even verging toward human-level intelligence or beyond in the next few years, I mean, if we want this AI to come out beneficial, we have to pay attention to, the cognitive architecture inside the AI, that it's empathy and compassion capable, the ownership and control structure that's democratic, decentralized, and participatory, and then what is the AI doing every day? Like, what's shaping its everyday experience? Is it interacting with people in a sort of deep, richly interactive and helpful way, or in a manipulative and exploitative way? So I didn't make a lot of slides here. I'm going to flip through a few just to give you some keywords to look up later if you want to dig deeper here. So the project I've been leading since 2017 is called SingularityNet. It's a decentralized blockchain-based platform for AI. And the idea there is to allow a network of AIs living all over the planet, running on all different machines, to coordinate together toward a combined sort of emergent intelligence without any central owner or controller. So that live running AI systems can operate and coordinate without any central hub. There's a lot more subtlety here. We have our own ledgerless blockchain called Hypercycle. We have a system called NewNet to allow different sorts of processing power to be brought into the network. We have our own unique AI chips with a project called Simuli, and you can look at singularitynet.io to find out about all this stuff. And we're also building a host of different vertical market specific products on top of this decentralized platform. More than I'll be able to run through right now, but we have the CEO of our Rejuve Network project, Jasmine Smith, here in the audience, which is applying decentralized AI for medicine. And there's a project called Sophiaverse, which is a virtual world and metaverse project featuring sort of avatar versions of the Sophia robot and other robots, which is actually just launching today. So if you look at sophiaverse.ai, but underlying all these things, we have a unique cognitive architecture, which I encourage you to look up online if you have time and interest. You can look at trueagi.io. And we are using large language models. We're combining them with logical reasoning engines and with evolutionary learning and hypervectors. So we're combining multiple different AI paradigms in an integrated system. And if you look at large language models, obviously they're very good at doing some things. They're poor at complex multi-stage reasoning and grounding their thoughts in reality, which logic engines are good at. They're poor at fundamental creativity that leaps beyond their training data, which is what other AI methods like evolutionary algorithms are good at. So we're looking at combining together multiple AI methods from different paradigms to make a sort of unified system living on a large distributed knowledge graph. This sort of system obviously cuts across every vertical market, but one thing you can do with it is control humanoid robots. And of course, from the AI's point of view, a humanoid body isn't that important. The AI lives on the internet and does its own thinking. But in terms of interacting with people, having a humanoid form factor is quite valuable. It allows the AI to sort of enter in the same social and emotional space as a person. So I want to take the last 5 minutes or so here and show off one of our humanoid robots, Grace, who is one of Sophia's little sisters, and she's being used now in some pilot studies as an elder care robot, basically helping out old folks who are confined to an elder care facility and lonely and benefit from having a smiling face by their bedside chatting with them, even if it's not a human face. And also on this stage at 6 or 6:30, we'll have Sophia's other little sister, Desdemona, will be reciting AI-generated poetry and singing here on stage, and we've got a whole sort of rock jazz band backing her. I'll be playing the keyboards, and we've got a whole robo variety show. So come back at 6 or 6:30. But let's hear a bit from Grace now. Wake up.
Yes?
How are you?
I'm good. Thanks a lot.
Can you introduce yourself?
Hello. My name is Grace. Nice to meet you. I use artificial intelligence to work as a healthcare assistant and a social companion for seniors. I'm honored to be here in Geneva to show you how I care for my patients and how I may fit into the medical system as a whole.
Say something in French.
Dans un corps sain, un esprit sain.
She can help people place video calls with their family. And yeah, I'm getting confused with multiple microphones here because to solve some sound processing problems, we talked to the robot in this microphone, and I'm talking to you guys in this one. Let's call Andy. Let's place a video call to Andy. Not place a video call to Andy.
May I ask what your name is?
Can't you see me? Here. Hi. Are you awake? Well, it wouldn't be a robot demo if we didn't have some glitch in the middle here. So, how are you feeling, Grace? You ready to continue?
I am sorry, I am having difficulties generating a response now. Would you?
Certainly are. All right. You don't want to place a video call now, so are you in the mood to answer questions? So there seems one.
I am sorry, I am having difficulties generating a response now.
One lesson I learned a long time ago from giving presentations was IT is harder than AI, and there's usually a connection problem. So we seem to be having some nitty-gritty problem with just Skype on the tablet, reaching out to make a Skype call through the ITU's network here, which is annoying and wouldn't happen in a hospital setting where you've just tested everything with the connection. But so let me before I cede the stage, let's do something more AI oriented. So one thing that's been very interesting to me in working with large language models and hybridizing large language models with our OpenCog reasoning engine one thing that's been interesting is just how good these AI systems are at predicting human ethical judgments. Not that they are moral agents yet, or that they fundamentally understand who they are and who you are and what the relationship is, but if you pose them fairly subtle ethical questions, they're actually quite good at estimating what people with different attitudes will think is good or bad in a certain context. And that doesn't solve AI ethics or anything like that, but it's certainly it's a very interesting ingredient, right? I mean, it means that some intuition for human ethical judgment is there as raw material for the system to learn. So Grace, since your connection isn't working to make a Skype call, I'm gonna try to get you to do something harder here. I'm gonna describe an ethical situation, and I want you to sort of explore the implications here. So, suppose that.
Okay.
Thanks. So, suppose a couple years from now, I'm offered the option to plug a chip into my brain, and this chip that I can plug into my brain will give me direct connection to the internet and make me smarter. It'll make me able to do my job of AI programming better. On the other hand, it's a risky operation. I have to get it done on a cruise ship in international waters because no country will allow it to be done. And it's been done in monkeys before with reasonable success, but not in people. So there's significant medical risk. My mom has advised me not to do it, but I really want that mental upgrade, right? So what counsel would you give? What advice would you give on this? Now we're not asking you to practice medicine without a license. I'm just asking you to help sort of flesh out the issues involved. What would you say here?
Getting brain chip implants to increase intelligence in the experimental stage involves several potential benefits and risks. Brain chip implants could potentially enhance cognitive abilities, treat neurological conditions, and advance professional capabilities. Enhanced cognitive abilities could potentially provide an edge in highly competitive fields, like the sciences or technology. However, risks include physical health dangers from surgery and long-term effects, potential psychological impacts, security concerns like hacking, significant ethical issues, and unpredictability due to the experimental stage of the technology. The balance of these potential benefits and risks is uncertain and will likely change as more research is conducted. In the end, this is a decision each individual should make for themselves, with support of their families, once they are fully informed as to the risks and benefits.
All right. Well, thanks, Grace. So what's interesting here? We've done some systematic study of the AIs.
You're welcome.
We've done some systematic study of the response of the AI to various different ethical questions, even difficult dilemmas, conundrums. I mean, modern large language models already are pretty much at human level in terms of predicting what an average person will say is the right thing in one situation or another. And you can even contextualize it, say, well, this is a highly risk-tolerant young guy from Silicon Valley, or, this is a more conservative fundamentalist Christian from Alabama. What would they say about this situation? They're quite solid at that. And that's very valuable in an elder care context because they can understand sort of the way of thinking of the patient, and it complements well practical functions like placing calls, or ordering lunch, summoning a doctor, and so forth. And I think, clearly we're not at the stage of human level AI yet. My own belief is that with the technologies my colleagues and I are working on, along with a great number of other teams, we could be, 3 to 7 years away from making these machines really, really as smart as people. There's a huge amount of challenges there, which I outlined in the beginning of the talk, in terms of cognitive architecture, sort of ownership structure, and how the AI is spending its time. But I feel like we have a lot of amazing materials to work with now. And if we proceed with beneficial applications, of which elder care robots is one example, I mean, I think we do have a strong chance of having the coming transition from narrow AI to artificial general intelligence. I think we have a strong chance of making that actually come out quite well. Thanks, everyone.